Last time when we talked, we were basically talking about all kinds of database management systems that exist in an organization. Now we need to take that database management system and convert it into transaction processing systems as they are actually handled by various organizations in the world. The big ones that everybody can relate to are transaction processing systems at the point of sale. These are things like ticketing. These are things that you check out of, and we've been using these examples for a long time. At the outset, what I would like to do is show you a video regarding this. So,
the SeaWorld family of aquatic parks comprise a unique environment. Within these 225 acres in Florida, exotic marine life coexists with over 15,000 daily visitors. How the crowds, the stars, and their habitats are managed is a story of practical applications of computer technology. Through these gates pass millions of families eager to see one of the most popular theme parks in the world. For the executives of SeaWorld, they represent more than welcome guests. They are a coveted resource that must be understood and managed if the business is to run efficiently.
Ours is really a very simple business. Once you master the thousands of details necessary to run a major theme park, that's where computers come in.
At SeaWorld, every ticketing transaction is different, depending on the number of people in a party. Do they have discount coupons?
I need 2 adults and 3 children.
Okay, 2 adults, 3 children.
Children under 10. Or senior citizens in the group. The ticket operator taps the data onto a special keyboard, and the computer system tallies the price corresponding to the combination of discounts particular to the group. Finally, the tickets are dispensed. The ticketers are more than just salespeople. They are the first step in a process of data collection and management that extends from the front gate
Thank you. You have a nice day.
to the executive offices, bringing order to one of the complex tasks in running the park. Much of the data flow at SeaWorld follows the same basic pattern. First, raw data are collected and entered into the system, where they are organized and stored for future reference. When users need information, they input the correct instructions, and the appropriate data are retrieved from storage. The data are processed according to the instructions, and the result is usable information. Beginning with the ticket vendor's input of raw data, the number of visitors in the party, current discount coupons offered for redemption, and cash tendered, management can learn how many people have purchased tickets during a given hour, how much money has been collected, and how promotional campaigns are performing. Such pieces of information are regularly prepared for many of the management reports the system produces. In the executive offices, an up-to-the-minute summary of the morning's activity is only a phone call away.
It's going to open at 11 o'clock.
We use computers to gather data and to process them into usable information. This information enables management to intelligently operate the park. It's that simple and it's that complex because there's a lot of information we need to understand on a daily, hourly, or even minute-by-minute basis.
Each keystroke of raw transaction data is the first step in a journey toward relevant, usable information. Instructions to the computer, called a program, direct the stream of data to a hard disk or other storage device, or another program places the data into the desired format and incorporates them into the park's database. The park has many programs designed to help management get the information they need from storage. One such program processes all the zip code data collected by the ticket vendors by sorting them in numerical order and analyzing patterns. When the zip codes are correlated with the geographical distribution of advertising expenditures, the marketing staff can evaluate the success of current promotional campaigns. Other programs are designed to provide attendance statistics, used to forecast crowds so an appropriate number of live performance shows can be scheduled, and to produce cash bag reports that provide an audit trail extending from the ticket vendor through the counting room to the bank deposit slip. SeaWorld is a remarkably diverse enterprise where each week millions of dollars are collected. An uninterrupted flow of data must be processed to allow the management team to keep its finger on the pulse of the business in this competitive marketplace. Every computer application at SeaWorld is predicated on the same basic pattern. Data are collected and input in the system, where they are organized and stored for future reference. When users need information, they input the instructions. The appropriate data are retrieved from storage. The data are processed according to the instructions and output as usable information.
We have found that as our database of facts increase, patterns are revealed which help us to better understand the mysteries of aquatic life and theme park management. Our understanding of such vast quantities of detail would be much less complete without the assistance of computers.
We have seen how SeaWorld uses computers for the well-being of the park and its inhabitants. These systems ensure the smooth operation of a major theme park, allow us a better understanding of our environment, and provide a true competitive advantage in this exciting marketplace.
All right, so let's move on. This, if you look at it, what we did was we did the same thing that we were talking about in the database management system. You are the end user, and you are accessing a database management system, okay? And that database management system is the one that allows you to get the outputs in the form of reports. This is an example of a transaction processing system. SeaWorld's ticketing system is a part of the transaction processing system that they have. We have many such systems around the organization. But first, let's look at the history of IS within an organization. Okay. All right. The moment you guys cannot hear me, you need to alert me by raising your hand or something like that. Now, if you look at it, there are three basic things that happen across organizations. When we first started, we started by using calculation systems. Okay. These calculators were designed primarily to improve the existing work you do. For example, if you take take one of you and discuss what your HR does, your HR is basically processing payroll, and the idea was just to make that counting of the payroll much better. We were not changing the task, okay? All we were doing was improving the efficiency of the task that was getting conducted. Examples of this technology: mainframe, punch card. You all remember mainframe. Floridians have to remember mainframe from the 2000 elections and the punch card experience that they have. But this was primarily focused on payroll and general ledger. Around 1975, what happened was new systems started coming in. Organizations started realizing that these calculation systems can be used for more than just adding up numbers. It can be used to store data. So what we did was we started using computers to improve operational efficiency and management of individual departments. This is also the time when computers had started coming up in every department, every person's desk, and people were starting to get familiar with computers. Okay, things like human resource management, order entry systems, manufacturing MRP too started to happen around this time. Later on, we will talk about integrated systems and business process based systems. But this is the generation that we are currently in. That's not to say that functional systems are not getting used. They are still getting used, but they are slowly and steadily getting integrated across the business process. We'll talk more about it later on. So, where do the functional systems come in? If you remember the idea of functional systems, if you remember the idea of functions, when we talked about our first session, we talked about a 1978 slide by Galbraith, where we basically said that because of the need of information of organizations to process information, we need to switch things. We need to create departments, okay? And that was the idea of creating these silo departments. It was because information was not traveling from one department or within a department very correctly, we decided to create departments. Now this has significant benefits. It allows optimization of expertise, groups like functions together for learning. However, if you look at it, just like we do at the Coggin College of Business or at the University of North Florida, every college is looking out for itself. We are all trying to scramble for resources. We are trying to get resources from one person, one college to another, one department to another. It is leading to significant sub-optimization. We are not able to look at the department as a whole. Does that make sense so far? Give me a check mark. All right, good. Moving on. What happens is, because of these individual systems that we have created, we come up with these systems. There are many such functional systems around us. Each department can have its own functional system. There's no reason for me to go in depth into any of these systems because we're not talking about any one particular system in the slides. What I'm trying to do is give you an overview of all of these systems. So the next few slides, they all talk about operational systems, in this case human resources, in the next case so on and so forth. But the idea is just all of these are basically database management systems, and if you spend enough time with one of them, you'll be able to understand it. All they do is they have different entities, different attributes, and different relationships, but the underlying concepts regarding operational systems is no different than a manufacturing system or an MRP system. Okay? Or, for that matter, accounting and finance system. Now, we do have a dedicated class in accounting and finance. Okay, we do have a dedicated class in accounting and finance system. I think we call it AIS, Accounting Information Systems. But from your perspective today, these are all the same systems. Yes, again, they do things slightly differently, but they're all exactly the same system. Okay? Again, another slide, marketing and sales system. Every system is focused on a slightly different thing. And then HR information systems. One term that I would like you to remember is this idea of OLTP, or Online Transaction Processing System. These are the same as any other systems that exist in the market today, like an HR system, except the fact that these are online. Okay. Now you have seen a lot of these systems around, and Amazon is a prime example of an online transaction processing system. Based on the information you have learned till now, these are not very different from any other system. In terms of networking and architecture, they get slightly different because in a typical functional information system, you're always connected to the program. Here, you constantly connect and disconnect. So there's a slight technical difference, but for the purposes of the ISM class, OLTP is just another transaction processing system, except for the fact that it's online. Okay. However, this creation of functional systems across an organization, so dividing you into functions across an organization, as I said, led to significant sub-optimization. Around this time, around 2000, what also happened is processing power of computers increased tremendously. And this processing power of computers and the ability to store data, not in a mainframe, but in a server class machine and larger machines which you could access much faster, led to a movement towards enterprise-wide information systems. These are information systems that exist to integrate things across an organization. Now, what I would like you guys to do, either in a chat or I'll open the forum, just press the sound key, the audio key, and speak up. I would like you to give an example of a functional information system that you interact with every day. Facebook, that does do transactions, that's true. Siebel, online banking, excellent. I need two more. MyWings would not be a transaction processing system. MyWings is more of a portal. Okay, it doesn't do a transaction on its own. It just connects you to various transaction processing systems. Wealth management system, yes. Yes, excellent examples here. Excellent examples. QB Online, JD Edwards, these are all examples. But we'll come back to JD Edwards in a minute, and Siebel also in a minute. But you guys get an idea. You've been interacting with these systems for a long, long time. So let's move on. Let's talk about the current reality that exists, enterprise systems. Okay. Now, if we look at any organization, there are multiple kinds of functions that happen inside an organization. Okay, there are some parts that are core to an organization. Okay, that don't interact with anything outside the organization. They just interact with the people inside the organization. Manufacturing. Is a typical example of such a thing. Whereas sales is an example of something that interacts with the outside world. Okay? The idea here is, on this slide, is to understand what a boundary spanning unit is and what are the core activities. Okay? An ERP system okay, an ERP system is primarily focused on everything that's inside the organization. It stands for Enterprise Resource Planning. So anything that's inside the organization is game for an ERP. But anything that interacts with things outside the organization, that an ERP does not handle. So let's keep rolling on it and you'll understand it much better. What does an ERP do? ERP provides a cross-functional process view of the organization. How many of you have finished your IS2 regarding ERP? Please raise your hand. All right, you guys need to get on it. We don't have a lot of time. You have barely a month to get your IS2 done. All right. But if you look at your IS2, one of the things you will find in the demo of ERPs there that you go through is people can see it across various functions. People can see when finance can see what discount sales gives, sales can see the overhead across other departments. ERPs also force you into a formal approach, a formal business model. Okay, let me see if I have a slide on that. Okay, ERP forces you into a formal business model. We'll talk about that in a second. ERP maintains data in a centralized database. All of those functional systems that we said, all their database is now one DBMS. Okay, ERP is very, very difficult to implement. Okay, but as the diagram shows, there is a pot of gold on top. The benefits are very, very large. Okay, it's very, very difficult to implement, but the benefits are very large. That's why most companies are still going for it. And ERPs are expensive. These I've seen them cost as much as $4 million. Okay, and the project's still getting failed. I've seen companies doing it for much less and succeeding tremendously based on that. Let's break each one of these points down further. First, ERP takes the big picture view. It takes the process view. I recently ordered a computer from Dell, okay, and naturally it got lost. I just have that kind of luck, and it got lost. Okay, and I wanted to contact people as to where they are. Now, if you think about yourself, none of you would be interested in the fact that the computer is stuck in manufacturing or a part hasn't come from Thailand. We just want our computer. All right? And guess who contacted me? It was a process manager. A new breed of employees have started to come in. These employees are primarily responsible for looking across different functions in an organization. Okay, the idea here is to reduce the duplicate effort. It facilitates cross-functional communication, and optimizes something that the customer is really interested in. Okay, really interested in. J.D. Edwards. That's what Phil had as an example. J.D. Edwards does exactly this. Other softwares that do exactly this are SAP. Okay, examples are SAP or Oracle. Oracle ERP, they call it, I think. Oracle applications. These are all examples of ERPs that allow you to do that. ERPs also put things into one central database. That's a huge property. Let me explain to you why this is important. There are two reasons. The first reason is agreement. Okay. Now I'm going to ask you a question, and I want you guys to either say it or just type it in. I'm going to turn my mic off so you guys can talk. But what is profit? All right, so we have total revenue minus total cost, revenue minus cost. We have amount left after cost and expenses. This one's interesting, amount left after cost and expenses. Now, if you look at it, profit, my question, is a very straightforward, simple question. This is something that we learn in the first time we touch any profit and loss statement, we touch any business class. You have to know what profit is. Let me give you an example here. This is what accounting profit was. I worked in a firm where we have this concept of transfer pricing. Okay, transfer pricing stands for the fact that the manufacturing created goods and then at a certain price transfer those goods to the salespeople. The salespeople then sold it and they got a commission on it. What do you think their definition of profit is? What do you think their definition of profit is? Salespeople are trying to sell. What do you think their definition of profit is? They get it at a certain cost and they sell it. Sales minus margin, cost and the price to sell it. Okay. Now, if you look at it, is this the same thing as the profit that you guys had mentioned earlier? Say, checkbox yes, tick yes if the definitions that were spoken earlier and sales are and the later one are the same. Click cross if you think the definitions are different. Okay. Now, just this simple example, something that is so obvious, okay, something that is so obvious is so different in organizations. Every department thinks about profits so differently, okay, and that gets into trouble. Okay, when we get into board meetings, we spend a lot of time trying to make sure that the terms mean the same thing so that everybody's talking the same numbers. Otherwise, everybody's starting to interpret them very, very differently. ERPs force us to do that. Okay, ERPs, because everything has to go into a central database, everything has to mean the same. And this is where the big challenge for an ERP comes in. In one of the implementations of ERPs that I was a part of, we spent 4 days trying to come together on what an accounting code should be. Okay, those just a standard accounting code, what it should be in a ledger. Okay. And 4 days is what it took us. Okay, and you guys all know based on previous class that accounting code is nothing but a primary key and has no real significance. But it took us 4 days, and this is where the challenge for an ERP comes in. It is the people part of it. It is getting agreement on various aspects inside an organization. Okay, the second thing it does is because everything is in a centralized database, there is limited duplication, or rather there is no duplication of data. And because there is no duplication of data integrity can be maintained much better. People are not changing spellings across departments. People are not using different abbreviation. Everything can be tracked to one person. For example, banks are exploiting this a lot more than they used to. Earlier, each account was evaluated individually. Now you are looked at as one central customer because all your accounting statements, all the investments you've made with the bank are in that central database, and they are able to pull it out together. Okay, so this is the anatomy of an ERP system. Central database, agreement on business processes. At the bottom of the slide, I have two questions. Should we select one vendor for an ERP, or can we have multiple vendors of ERP working? And number two, when would an ERP be appropriate for an organization? I want you to start thinking about these questions. I'll come back and ask you these questions in a minute. Now, ERPs, as the previous slide shows, can do a whole range of things. Okay, they can do a whole range of things, from analytics, finances, human resources, operations, corporate services. This slide is nothing but functional information systems. That's all it is. Just the fact that they are accessing a central database allows us to integrate all of these functional information systems into one gigantic ERP package. It also means the fact that ERPs are nothing but database management system. Obviously, they're extensively large and they're extensively complicated to implement, but they are nothing but database management system, and that is why database was important. We'll take a 2-minute break here, and I'll look over the chat, and if you have any questions, please type them right now. I also have a request for somebody to look at their connection, so I'll look at that right now, but I'll open the chat up and open the speakers up so that you guys can talk. All right? Looks like everything is very clear to everybody, and nobody really wants to say much. Tell me something. Rather, let me get through the ERP section. This is how the ERP is defined by the Department of Navy. Okay, the Department of Navy defines ERPs as the integration of business processes that optimize functions across enterprise. ERP solutions provide consistent, complete, relevant, timely, and reliable information for decision making. This is probably the best definition of ERPs I have seen for a long time. Okay, and this is what they allow us to do. Number one, they allow us to transform majority of our business processes. Okay, ERP is a key enabler of business process re-engineering. Facilitates standardized processes, incorporates industry's best practices, and ERP is less about technology and more about people. Now let me go back and ask you the question, when should an organization implement ERP systems? Is there absolutely anybody speaking using audio, or you're just reluctant to use audio, or can I not hear it? Why don't Early, okay. What do you think in reference to business process reengineering? Let me ask you a question. Should business process reengineering, you understand what business process reengineering is when you're trying to do the whole process again, or do it differently and automate a lot of activities. Should business process reengineering be done simultaneous with ERP? Doesn't it create a lot of chaos? ERP would cause chaos anyway. I think you guys are brilliant. Not a lot of people understand this. You should not implement, and again, the idea is not. You should not implement an ERP system if you're not willing to change. Okay, ERP is too big of an investment to do if you're not willing to change. ERPs are used as a vehicle of change in an organization. Okay, it is that change in an organization that allows companies to become better. Okay, and that change is primarily done in business process reengineering. Standardized processes I have talked to you about. Industry's best practices. Let me emphasize this somewhat more. The reason why we do ERP systems, let's take an example here. Let's suppose Charles is starting a branch of or is starting a new business, new bank. Okay, Charles, do you have audio? Okay, then please type. Charles, if you are starting a new bank, would your checking process, the standard checking account process, be significantly different from anybody else, any other bank? Probably not. Would you want to go out and discover the whole process, or would you like to look at industry's best practice and start doing that on your own? You like to copy one that works, right? And that is what companies are able to do. I'm going to push a URL out to you guys just to have a look here. Just scroll down and up the page and look at the industry that you are working in. This is the website of SAP. SAP is a leader in business process in ERP systems. Okay, and you can find your industry in here: high tech, engineering, consumer products, etc., etc. What SAP says is that I have implemented, or ERP systems have been implemented in so many companies. ERPs have been implemented in so many companies that we have now gone in and done a study of all of these business processes, and we are now benchmarking across the best in the world. And so, if you get an ERP, you get the best business processes. Okay? Any questions so far? Philip says David fell off. How do you reconnect? You just go in and you go through Blackboard and you just join the session again, and you'll be able to connect. Any questions so far? All right, next question is, when should we not Best practices for some may work for others. That leads me to another question. When should we not implement processes the way the ERP has? Melissa, small companies, let me pick on that. Why small companies? When they're not willing to change is not a good enough idea. The idea is you have to force the change. This ERP has to come down from the top, and you have to force the change in here. Okay, I've read through the comments here as they were coming in. Let me respond. Two things. Okay, number one, not all business processes are amenable to changing. Why? Because some business processes that are unique to you might be giving you, and this is the only reason why you should change an ERP system, might be giving you a distinct competitive advantage. One of the problems with benchmarking across the world is the fact that that everybody has information regarding the best processes in the country, in the industry. But if your business process is giving you a competitive advantage, you might want to change the ERP to suit your business process. Okay. Then price prohibits, and small companies. That's correct. However, ERPs are available in different flavors. Most ERP companies will charge you based on your annual output. And the concepts of an ERP need to be in foundation early, because otherwise later on it gets very complicated. For example, even to Melissa's point, this idea of small companies implementing ERP systems, they need to implement ERP systems. At least the idea of a central database needs to be harbored in. Second, if companies are planning to go big, it's better to bank on an ERP and start going along with it as soon as you can. Okay. Third question I had from Robert was industries that can't automate manual labor might not want to implement ERP systems. Guess what? Most building contractors today have an ERP system implemented. It is not about doing the job, doing the manual labor. It's about information processing. Okay, it's about information processing. Let me go back and look at if you have any questions. John, what I'm saying is you might not want to implement that part of the ERP system. You might want to go ahead and configure. ERPs are very flexible systems. You might want to go ahead and configure the ERP to suit your needs. Let me explain that on this slide, how you implement an ERP system. In an ERP system, what you do is you first go in and figure out what the as-is system is. Then you look at it, you compare it with respect to what the ERP, these standard processes of vanilla ERP or the best processes are, and you identify the misfits. It is at this time when you basically say, I should change the organizational processes or I should modify the ERP system. 9 out of 10 do not do this. Okay, just go with the plain old ERP system. I want you to type in why I am saying this. Okay, and I'll look at those responses. Modifying the ERP, as I said, competitive advantage is the only reason why you would modify the ERP system. Once you have done that, you prepare a detailed plan of implementation, train users. We'll talk more about that in a minute. You simulate and test the ERP system. The process of data conversion itself takes a long time. Okay, it's a very, very complex process, because think about it. You have your assumptions in your functional systems. You have your assumptions regarding how the reality is, and that reality needs to change to conform to what the reality assumption is in the ERP system. Okay. Then you convert into the new processes, and you convert to the ERP, and most importantly, it gets really, really difficult because ERP does not give you your bread. You have to continue to earn your bread at the same time. All of this needs to be done while you are running the business. That's where ERPs get into trouble. Okay? So my question was why I am saying that organizations need to implement ERPs as far as possible the way it is without modifying the ERP system. You can speak or you can type. The question is, why am I saying that you should implement an ERP the way it comes? You should not modify, you should not change things in an ERP to suit organizational needs unless it is giving you a competitive advantage. Excellent points, and that is absolutely correct. See, the problem, and this is where the dichotomy comes in. The problem with ERP systems is the fact that they ask for a lot of change from people, and it's the people component that gets organizations into trouble, changing the people. However, on the flip side, if you change a lot of the ERP to suit the people, then you're going to get into trouble with upgrades, with maintenance, and you'll basically end up adopting a complex piece of software for which you are paid for. Okay, and all of the points that have been said in here are exactly right. Okay, so that's the reason why you maintain you should implement it as far as possible. Do you understand the ERP section now? Okay, it's a large piece of transaction processing system integrated across processes in a central databases, forces you to standardize processes, very difficult to implement. The problem is with agreement on processes and change in people, but if you implement it correctly, there are lots and lots of benefits. If you understand this, the ERP section, please give me a checkbox. Yes, your question regarding SOAs, we'll come back at that in the next set of modules. SOA will get complicated if I start talking about it right now. All right, we have a check mark from pretty much everybody. Eric, Jeffrey, you guys need to tell me if you got ERPs. John. All right, I'll assume that we can move on. ERPs. The next big piece of software that we have is CRM. Okay. Now, why don't you guys? So let me ask you this, and you guys can use the cursor and other things too. I can see that, but type this in. When does a customer become a customer of a company? When would that data? When would a customer's data be available in an ERP system? And what is that first point of contact? At the order? For sale, point of call. Excellent, excellent. Now, for some of my more marketing-twined people, when is a customer considered to be a customer? I guess Victoria already has the answer to it. She was, I hope she was writing it for earlier. Okay, and that is the problem. ERP systems do not recognize a customer till they've had some sort of an accounting relationship or resource relationship with the company. CRM, on the other hand, recognizes that customers are the core of our business, and we have to manage relationships with them. Okay, and it is that model that the organization uses, that CRM systems use, that make it very different from an ERP system. What CRM systems do is they go from attract, sell, support, and categorizing the customer, and then winning it back. That is the philosophy. For an ERP system, this is it. This is all that would have been. This part would have been captured in an ERP system. Nothing else would have been captured in an ERP system. So you see exactly how philosophically different this system is. It concentrates on a customer even before the customer becomes a customer. Okay, and you go from target to customer to all the way back to, in this case, to actually understand it. Okay, so again, can you appreciate the difference between the two large systems? The philosophy behind an ERP system is management of internal resources inside a company. With a CRM system, it's a boundary spanning unit. It is focused on even taking data in about customers that they haven't even touched yet. As soon as Alexander says, as soon as they are a part of the sales region, it becomes a part of the CRM system. Siebel, as I said earlier, somebody said Siebel. I don't remember the name. Siebel is an excellent example of a system that does all of these things. Another big example of a system that does a lot of these, Robert said it, that is becoming now, is Salesforce. Okay, Salesforce is trying to get at this level. Again, I'll ask for your checkbox if you understand the difference between an ERP system and a CRM system. It's a philosophical difference. The concept of processes remains the same. You're looking across processes. You're able to track a customer across all of these things. However, the philosophy is very different. Okay, as most of you checking through, again, the same idea, central database, 3 basic components, all leading to a central database. And these are the functions that are getting done. So, this is a recent study that came out, which basically outlines the benefits of CRM. CRM benefits can be seen at 3 distinct levels. CRM implementation benefits, and this is obvious. I mean, this is not something that that we were surprised at, but the research validated everything that we were saying. Benefits can be seen at an operational level, at a tactical level. So this is at the actual salesperson level. This is at the branch manager kind of level, and this would be at the head office, where we are seeing things in the way sales are increasing, and all of these improvements are creating a significant advantage, competitive advantage against other people. Okay, so time for questions, comments. Time for questions and comments. The floor is yours. Thank you. Good night.